All right, so we're actually making a shift in this class now. I've given you some of the basic ideas of what SQL can do, and then we looked at the different data types, so you got a little taste of some SQL commands. What we're going to do in these next couple of sections now is dive deeper into SQL. So this first part, part 4, is going to be traditional SQL statements. I don't want this to just be about spatial SQL because there's so much you can do with SQL. I want to make sure that we're comfortable with that. The next part is going to be spatial SQL, so you're going to learn about the commands. And then finally, the part after that is going to be about building geographic models. And then we'll start to solve some actual problems in GIS using SQL. So the select statement in SQL, in Postgres, and Oracle, and even SQL Server basically selects data. And we can select individual rows. And that select statement also has clauses. We're going to look at a bunch of different clauses for getting a little more specific about what our selection is. So we've already toyed with this, but I figure let's just jump back into it again. And here I am looking at my query results, and I'm going to right click and say update SQL layer. So now I can just change this SQL to something new. So select TC parcel.star from TC parcel. So again, those are the parcels we've been looking at. And then this is our where clause. So where the PC is equal to 210, that's the single family residential properties. And we can come over here. Let's turn off, let's move the parcels up top for a moment. That's better. There we go. And let's update this data set once again. Okay, and we come in here, we can see our query results. And now you can see those single family residential properties. So they're the ones that are in this reddish color. And let's come back in here, and I'm going to change the color, make it something that's maybe a little bright. We can make it green. That's fine. And then hit apply. So those are our selected features. Now when we come back in here, you saw we did the select the TC parcel dot star. That means get me all of the columns, and this is what I have. Now I don't have to do that. I can say select TC dot, and I don't even have to say TC parcel. I could just say parcel key. I can say Muni, and let's look at a couple of others that maybe we'll be interested in. How about assessment, ASMT, and PC, and then geom from TC parcel. So let's execute that. And now you can see I've got a smaller set. This is also really beneficial from a query standpoint because with a GIS, when you use the wizard, it's going to bring you all the records. Here I can say I just want these columns, and let's get rid of assessment. Maybe I don't want assessment. I can just do it again. And then I can update that. Same features, but now I have different attributes and a smaller set of attributes. So if I paste this, I'm going to say select everything from TC buildings and TC Muni, where the municipality or this column is equal to full name. Well, before we do that, let's just try this. Select star from TC buildings, and let's say limit 100. I don't want to grab all of them, but let's make it quickly. And if I highlight that, I can execute it. So you can see all the different field names. And as we scroll through, there's something called municipal-I. Right? One of the reasons for this is this originally came from a shape file, so it didn't store the long field names. That's another great benefit of using a real database. So these are the actual field names. Let's do the same thing, but say TC Muni. There we go. And let's highlight that. So notice this municipal-I has the town names, or the name of the municipality. And if we look in here, we have another column I have to find. And here we go, we have full name. So notice these two columns have different names, the municipal-I and then full name in TC Muni. So what I'm doing here is I'm saying select everything from the buildings and the TC Muni where the municipal I name is equal to the TC Muni full name. So this is important when I have different tables that I'm linking together, just in case there's a similar field. So I can just run this really quickly, and we'll let this complete. Okay, that's done. And now I have all the records for TC Buildings and TC Muni. Now notice I have a geom column because that's the geometry. And we'll come through here. This is all the information about the buildings, even the year built. And now I get to the TC municipality and I have a geom field. This can be a little bit tricky to start to deal with. So let's do something like this. How about TC buildings dot star and say the muni type. Right, so this tells me the type of municipality, whether it's a town, a village, a city, and so on. So I can then execute that. That's completed, and then I can update this layer, query results, and let's take a look at it. And now you can see I have buildings that have gotten selected. Why is that? Well, pretty easy. I am bringing in the TC buildings dot star and we're looking at the geometry field. So we were looking at parcels before, but QGIS doesn't really care as it's hitting back against Postgres. And then I can come in here and I can click on some information about that building. And again, the nice thing is I've got all the information about the building and I've also gotten the Muni type. So this is kind of a way to join or relate tables together. Let's check out another kind of join, and I think this is an important one. You can see that there are wizards that allow us to join data all the time, but let's go back into one of our data sets. And I'm going to come in here, and I'll paste that in, and I'm going to get rid of, and you can do the same thing, this PC : text. So I want the geometries, I want the Swiss code, which is like the parcel. Let's make it parcel key, why not? Okay. And the property class from the land use description table from TC parcel and LUDESC, where the PC, the property class for TC parcel, is equal to the land use description BC. Let's do this again what we did before, which is select star from LUDESC. Okay, let's say limit 100 again, just because I want to see a few, just to get an idea of what's in those records. So you can see we have different property classes. 485 is commercial. And we scroll down through some of these. Again, here's 210. That's that residential, right? So that's a single family residential that we're looking at. So we have a bunch of those. All right, so what I'm going to do now is run this query. And again, you have PC and the prop class. And when we run this, watch what happens. I get an error. Why? Well, one reason why is I spelled parcel key wrong. Actually, let me just run that again so you can see what Postgres does. This, I think, is super cool. It doesn't exist, this PRCE3L key. And then it says, hint, perhaps you meant to reference the column parcel key. That's really cool, that it's actually helping me along the way. Sometimes you luck out and you get something like that to occur. All right, we have a problem again. And let's see if it gives us any other hints that might help. No operator matches the argument types. You may need to add explicit typecasts. Well, here's our problem. And again, if we look at LUDESC, and we can go look at the table, info about it, the columns is an integer value. But if we come down to TC parcel and we look at PC, that's a variable character field. We have a problem. And that problem is we're trying to find the TC parcel PC column that equals the LUDESC PC column, but they're two different types. So this is one of those examples where you might ask, well, what do you do if you are using a traditional GIS in the wizards? Well, this won't work. the column types are different. You have to create a whole new column of, like, say, type text. Then you have to copy this PC column into that, and then you can relate it, right? That's a lot of work. Instead, I'll just say text. Well, that finished up, and you can see I've got all of my different records. One of the other things, let's just also put in, oh, I don't know, the prop class. So let's run this. Actually, no, not prop class. Let's do tc parcel dot PC. That's fine. So let's execute that. Now it's done. So here that 210 is residential, the 300s are vacant, and so on. The point of this exercise is just that we were able to join two different tables on a field that was common to both of them. Well, we're getting a little long here, so I want to just move ahead. Some of the other things we can do is have some other quantifiers called all, any, limit, sum, and offset. So let's look at our states for a moment. Hit Control C and we'll copy this. And let's put the states in here. And let's just say select star from states first hand. So let's execute that. That's done. Let's load it. And then let's look back at our layer. So this is a different one. It's called Query Layer 2. So let's zoom to that layer. All right, so these are all the states, and they have obesity values in them for different years. So here's the obesity in 95, 2000, 2009, and so on. So let's just I'll copy this again, and let's quit out of this and right click and say update. That way our window will just be connected to the layer. So here I can say select star from states where the obesity value is greater than, let's say, 20. So where the 2009% obese is greater than 20%. And you can see I've got 46 of them. Let's make it 25%. Okay, there we go. So there's a few less. There's 38 states that have over 25% obesity rate in 2009. Here's what I'm interested in, though, is let's select the obesity 2000. Here's another query. And if I run that, these are the obesity rates. I get a bunch of values. But here I want to say select everything from the states where the 2009 obesity values is greater than, and then let's copy this back in, then all of the records that come from this query. So this query gave me all of these records, and whatever the highest one is going to be the one that we're going to be checking with. So I want to make sure that it's higher than all of these. And there we go. So now we have 38 rows that are actually have an obesity rate that's higher than the highest value of these states. We can add more math. How about something like this? Plus or times 1.2. So 20%. Let's even run this real quick. So now we've multiplied it by 20%. Now I can run this, and now there are 13 states that are higher than the highest value that I've increased by 20%. So that's how the all command works. Let's jump into the order and also the limit clause. So here I'm going to say select, let's go back in here. So I want to select star from the states, so all the states, but I want to order it by the obesity values, DESC in descending order. So the first record is the highest, and it goes down. But I want to say limit 5. In other words, I'm interested in knowing who are the 5 most obese states in 2009. We'll run that, and here is our record. So there's 5 rows because I asked it to limit 5. Let's update it, and let's come back in, and these are our 5 states that are the most obese in the US. The next thing I can do is offset them. Let's come back in here, and I think we can just say, I think it's name. Let's say name, comma, geom. So these are the 5 highest obese states. Let's do the same thing. Geom, comma, name. So I'm going to offset 5. So now I'm into West Virginia, Alabama, Arkansas, Missouri, and Michigan. What this is saying is I want 5 records, but I want you to order it in descending order. highest to lowest, but then I want you to offset 5 of them. So skip the first 5 is what I'm saying and get me the next 5. And we can move to our next section here, which is looking at ordering. So that we've already kind of played with that. We ordered by obesity 2009 in descending order. I can also do it in ascending order, so lowest to highest. And I can also say ASC to be more specific, and it'll give me the same results. So I can order in descending or ascending order that you can see here. And we won't bother running these, but you could run them yourself. This is now sorting by the assessment value. So I can get, and I can also again use the limit clause to get the 30 most expensive or highest assessed properties in Tompkins County. Another one I really like using is the between clause. So this returns the value of an expression if it falls within a range of values. This is really useful when you look at a command like this. Select star from TC parcel where assessment is between 100,000 and 200,000. Now the way a lot of us are used to doing this, we might say select star from TC parcel where ASMT is greater than 100,000 and ASMT is less than 200,000. So that's going to work. Right, we can do something like that, and we'll run that, and that gets me 25,000. Actually, I've made it 2 million. That's better. Let's highlight this again and select it. Okay, 10,990. Or I can say where it's between the two values. This is a little different. I can, because I've got the greater than, I can say greater than or equal, less than or equal, and execute that. There we go. So same number of records. I have a few that are dead on 100,000 and 200,000. But look how much more terse the between operator is. Another really useful one is using the in operator. This determines whether a value or an expression is equal to any of several that are in a list. We kind of did that before where we wanted to make sure that it was larger than any. But here's an example. So we can say select property class from LUDESC where the property class is greater than 500. And that's going to give me recreation and community service, public service, forest. So what I want to do is select star from parcels where the prop class is in this result. So now I've got 2,000 records that were selected that are within, and actually let's say prop class. Right, so these are the public service, community service, and forest, and you see a whole bunch of those. The other thing I can do, I can say where prop class is in commercial, quote that, public services, and recreation. So I'm giving it 3 values. Oops, I got a little error here. Okay, that fixed it. So this gets me all, and I can also get the geom as well, of course. So something like that, and execute it. So now I have my different records. So I can pass it individual values that I know about, or I can take the result of another query and pass it that column. Now I can't, watch what happens if I say prop class and PC. This is going to get me 2 different records if I execute this. So this is going to fail because we're looking for a list, and I just gotten 2 lists of records. So again, we need to only get 1 record to be returned. So that gets us a good understanding of the select statement and some of the variants we can have with alternating the where clause, also ordering data, selecting things that are in a certain range of values, and so on. So let's move on next, and we'll start to look at aggregate clauses.